Mathematical transformations describe how two-dimensional figures move around a plane or coordinate system. A transformation is a process that manipulates a polygon or other two-dimensional object on a plane or coordinate system. A preimage or inverse image is the two-dimensional shape before any transformation. The image is the figure after transformation. There are 5 types of transformations. Dilation. The image is a larger or smaller version of the preimage, shrinking or enlarging. Reflection. The image is a mirrored preimage, a flip. Rotation. The image is the preimage rotated around a fixed point, a turn. Shear. All the points along one side of a preimage remain fixed, while all other points of the preimage move parallel to that side, in proportion to the distance from the given side, a skew. Translation. The image is offset by a constant value from the preimage, a slide. You dilate a preimage of any polygon by duplicating its interior angles, while increasing every side proportionally. Which triangle image, yellow or blue, is a dilation of the orange preimage? The yellow triangle, a dilation, has been enlarged from the preimage by a factor of 3. Next we have reflection. Imagine cutting out a preimage, lifting it, and putting it back face down. That is a reflection or flip. Which trapezoid image, red or purple, is a reflection of the green preimage? The purple trapezoid image has been reflected along the x-axis. You do not need to use a coordinate plane's axis for a reflection. Now let's look at rotation. Using the origin 0, 0 as the point around which a two-dimensional shape rotates, you can easily see rotation in all these figures. A figure does not have to depend on the origin for rotation. Our next transformation is shear. Here is a square preimage. To shear it, you skew it, producing an image of a rhombus. When a figure is sheared, the area is unchanged. A shear does not stretch dimensions. It does change interior angles. Finally, we have translation. A translation moves the figure on the coordinate plane without changing its orientation. Which octagon image below, pink or blue, is a translation of the yellow preimage? The correct answer is the blue octagon. The blue octagon is a translation, while the pink octagon has rotated. Now that we know the 5 types of transformations, we need to learn which are rigid transformations and which are non-rigid transformations. A rigid transformation does not change the size or shape of the preimage when producing the image. A non-rigid transformation can change the size or shape, or both size and shape of the preimage. 3 transformations are rigid. They do not change the size or shape of the preimage. The 3 rigid transformations are reflection, rotation, and translation. The image from these transformations will not change its size or shape. The other 2 transformations, dilation and shear, are non-rigid. The image resulting from the transformation will change its size, its shape, or both. Transformations can be combined. A polygon can be reflected and translated, so the image appears apart and mirrored from its preimage. A rectangle can be enlarged and sheared, so it looks like a larger parallelogram. Here is a preimage and image. Which 2 transformations were carried out on it? The preimage has been rotated and dilated, shrunk, to make the image. On a coordinate grid, you can use the x-axis and y-axis to measure every move. The lines also help with drawing the polygons and flat figures. Focus on the coordinates of the figure's vertices, and then connect them to form the image. Here is a tall, tan rectangle drawn in quadrant 3. We are asked to translate it to new coordinates. Mathematically, the instructions look like this. This tells us to add 9 to every x value, which moves it to the right, and it tells us to add 5 to every y value, moving it up. Let's start with the point at -7, -1. We add 9 to our x value of -7, which gives us a new value of 2. And we add 5 to our y value of -1, giving us a new value of 4. The new coordinates for this vertex is 2, 4. Now, do the same mathematics for each vertex and then connect the new points in quadrants 1 and 4. Rotation using the coordinate grid is similarly easy using the x-axis and y-axis. To rotate 90 degrees, multiply the y value times -1 and switch the x and y values. To rotate 180 degrees, multiply both the y value and x values times -1. To rotate 270 degrees, multiply the x values times -1 and switch the x and y values. Reflecting a polygon across a line of reflection means counting the distance of each vertex to the line, then counting that same distance away from the line in the other direction. If the figure has a vertex at -4, 5, and you are using the y-axis as the line of reflection, then the reflected vertex will be at 5, 4. Shearing a figure means fixing one line of the polygon and moving all the other points and lines in a particular direction, in proportion to their distance from the given fixed line. Italic letters in a computer are examples of shear. Mathematically, a shear looks like this, where m is the shear factor you wish to apply. To shear horizontally, xy transforms to x plus m times yy. And to shear vertically, xy transforms to xy plus m times x. Dilating a polygon means repeating the original angles of a polygon and multiplying or dividing every side by a scale factor. If you have an isosceles triangle preimage with legs of 9 feet and you apply a scale factor of 2/3, the image will have legs of 6 feet.